Okay, so we're going to continue using MicrobeTrace to visualize sequence data. In the past, in the other videos, we've shown visualizing contact network and demographic data. This time we're going to focus specifically on the sequence data that arise from these types of investigations. So first I'm going to show you what those sequences look like. So here we have a FASTA file where first on the first line you have the ID, and then on the second line you have the actual character sequence of the genome that you're looking at. And so that's the file type we're going to begin working with. So I will load the sequence file. It automatically determines that it's a FASTA file, and then we can look at the alignment settings. We're not going to do any alignment for this particular file type, but I just want to dive in and explain the intricacies around aligning a file, whether you need to, if your file is already aligned, like you've already used it for another phylogenetic tree, or you've used those sequence files previously for some other project, they're most likely already aligned. A common tool that's used to do that is called Mega. That's usually easily accessible and free on Windows. But if you have not aligned your sequences, you can click the alignment settings and it's going to bring up this pop-up window. It gives you a brief preview of what your alignment looks like, and you can see pretty well that these sequences are all very lined up. So all the little colors that you see on screen represent A's, T's, G's, and C's, and so you can see kind of vertical lines representing similarity from sequence to sequence. If it doesn't look nice and aligned like you see here, then you likely do need to align the sequences, in which case you would click Smith-Waterman here. And then you can specify some of the specifics of the algorithm. You really don't need to do any of that. Ideally, you would just scroll down and hit confirm. If you are working with a different pathogen than HIV, you will need to use a different reference sequence to align the sequences to. By default, we align it to the polymerase region of the HXB2 reference sequence. Now, this is a subtype B HIV sequence that was first isolated in the early 1980s. And it's commonly used simply because it's a good example of the subtype B virus that represents about 95% of cases in the United States. If you have a different region of the HIV genome or a different bug in particular, say TB or hepatitis C, then what you would do is pick a reference sequence that you're interested in, and that's got to be saved as a separate file for you to access it here. As I mentioned, we're not going to align since this sequence data set is currently aligned. And then we will jump in and visualize it. So as soon as you hit launch, it aligns all the sequences and compares genetic distances between each of those sequences, and then renders the visual on screen. And so we'll move things around to kind of get our bearings. We see a few tight clusters, a few smaller ones where there's only 2, 3, and 4 individuals. But ultimately, we're most interested in this large cluster here.